Let's look at something fun called Pascal's triangle. This was named after the French mathematician and philosopher Blaise Pascal, who was working in the 1650s. Although versions of what we're about to look at have been found in places like ancient Chinese tablets and such. But it was named after him because, I don't know, he was famous and he related it to something else, which are called binomial coefficients, which we'll look at in just a moment. So the triangle works like this. Start with a 1. Now under it, write 2 1s. Now under that, keep writing 1s in the outside spaces like this, but then in the inside spaces, add these 2 up. 1 plus 1 is 2. So keep going in this manner. This is a 1. 1 plus 2 is 3. 2 plus 1 is 3. And we end with a 1. 1, 4. 3 plus 3 is 6. 3 plus 1 is 4. 1. So keep going like this. 1, 5, 10, 10, 5, 1. At some point, just grab your calculator and use that. Notice that it's symmetric here, so if we have an 84 is 28 plus 56, then 56 plus 28 is 84. What was the point of that? Well, you can notice a couple of fun patterns in this triangle. For example, if you look at this section here, you notice that we have triangular numbers 1, 3, 6, 10, 15, 21, 28, 36, and 45. But the really fun thing about this triangle is it represents binomial coefficients. So if we take something like x plus y to the 0th power, we get 1. X plus y to the 1st power, well, that's just x plus y. Or you can think about that as 1 times x plus 1 times y. If we take x plus y squared, you might remember doing something like called FOIL in a previous algebra class. So you do the first 2 x squared, the outside 2 plus xy, the inside 2 also xy, and the last 2 plus y squared. You combine those, you get 1x squared plus 2xy plus 1y squared. Normally we wouldn't put the 1's in here, but it's important because look what we have here. 1, 2, 1, 1, 2, 1. Does this pattern hold? Yes, actually it does, because x plus y to the 3rd power, you can write that as x plus y squared times x plus y. And now replace this x plus y squared with what you just found here and do the algebra. So you notice that after you do all the algebra, all is said and done, the row of the triangle here gives you the coefficients 1, 3, 3, 1, which you find here is 1, 3, 3, 1. So the same thing with the work to the 4th, 5th, 6th, 7th, whatever. You just look at the line that has that number there. So if you wanted to do something like x plus y to the 6th power, you don't need to work all this out the long way by multiplying everything. That would take a long time. You know, if you notice what's happening here, that we have an x cubed, then an x squared, then a mistake, and an x, and then no x's. And the y's go from no y's to y squared, another mistake, to y cubed. So what you notice is this pattern of decreasing x's and increasing y's along with the coefficients means you can write this as 1 x to the 6th plus 6 x to the 5th y plus 15 x to the 4th y squared plus 20 x cubed y cubed plus 15 x squared y to the 4th plus 6 x y to the 5th plus 1 y to the 6th. And so you save yourself a lot of time working that out algebraically.